Hello, my friends of Atari Labs. My name is Montoya. In this tutorial, what we are going to do is that we have two sedimentary layers. Okay, we have this layer and this layer. Okay, and then we have it as lines, but you can also have it as polygons. And from that, we have also a raster them, and then we have an area of interest. Okay, and then we have some dummy points that will help us to create or to perform better. Is those are dummy points that allows us to have more smoothed interpolated surface, okay, because we need a smoothed interpolated surface in order to define the orientations. Okay, so mostly for this exercise, okay, maybe in coming exercise we can only interpolate from the geological context, but in this exercise we need these dummy points. Okay, so well, we have point shapefiles, we have line shapefiles, we have a polygon. Besides of that, or actually these are polygons as well. Okay, so this is TE and this is TO. Okay, the uppermost layer is TE and the other is TO. These are extrusive rocks and these are also extrusive rock. Okay, so let's do our interpolation. So how we are going to do that? Okay, we are going to do that with Python and then with Aquifer App. And okay, there are several steps and some code related. I'm going to explain that. My advice is that you follow this tutorial and try to set it up for your own project. Okay, because it's not that easy, but if you get what we are doing, you can set it up for your own project with a percentage of success. Okay, so let's start. Okay, I'm not going to okay, on the description of the video, oops, you were not. Okay, on the description of the video, you have this zipped folder, and okay, but actually I made some changes, so actually you are going to see. Okay, so you just have to unzip it under your document folder, and then you have just to go and do Anaconda prompt cd documents, cd modeling, cd no, and here we launch Jupyter Lab. Okay, so here we launch Jupyter Lab. Okay, close everything. Okay, great. So here we have some CSV, that is where we are going to generate the files. This folder is actually produced by the Aquifer App, by Aquifer App. So actually we are going to replace. This is the raster folder where the DEM is located. We have some scripts, we have some shapefile, and then we have a place to store some BTKs. Okay. Okay, let's go to scripts, and let's start with process. Okay, so kernel, restart kernel and clear outputs. Okay, so we import the libraries, then we open the area of interest, and then we get extend. Then we have the dimensions that are around 9 kilometers times 7 kilometers, around that. And then we got the polygons. Okay, these are the polygons. Okay, and then the KDP is actually the basement, so actually that won't be, because in Gempy we work with the bottom surface, so whatever is not T or TO will be KDP, so we don't want that, so we just get T and TO. Okay, and then we open the raster them with Rasterio. Okay. since we have polygons, and in order to get the contacts and elevation, we work with points. We are going first the polygons. We are going to transfer to lines. Okay, and one polygon has two borders. Okay, the inner and the outer border. For especially for TO, that is why we are going to well, we clip lines. Well, actually, well, we are going to plot the geolines, and then, okay, so we have to identify, okay, for example, for TO, we have two lines, but the border, the bottom of TO is actually the outer line, so the index number 2 has to be removed, while for TE, we only have one line, and that's it. Okay, so with that we drop the index 2, okay, and then we just have the one line for the bottom of TE and the one line for the bottom of TO. Okay, then we extract the points along. Okay, then the lines we transfer that to points. Okay, and then we got some arrangement of the points, and then we sample. Okay, from these points we sample for the them. And why we sample that for the them? Because we want the elevation of these points. Okay, and then we create a new column that is elevation. Okay, so we have the points and the elevation. Okay, so and then we loop over that because for Gempy we need X, Y, Z and the lithology. So that is something that we do that X, Y, Z and the lithology. Okay, and then we work with some auxiliary points. Okay, so we open the auxiliary points because we need that in order to create the some surface in order to get the orientations. Okay, so for that we create a list, and then we join the list of from the points on along the line with the auxiliary points. Okay, and then we create a data frame, a compute data frame, and then we store it as model surface. That will be stored here on the CSV. Okay, this one. Okay, then for every layer, okay, we are going to interpolate the raster, and then from this, and then we are going to do and to store for each bottom, for each layer bottom, we are going to store that in a Python dictionary. Okay, and then from the, okay, so far we have a dictionary that for every layer bottom it has an array. Okay, and from this array, and by a selection of all the points, because actually they will get really, okay, you are not going to insert the orientation of all the points, so you just get a selection of those points. Where do we get the selection of those points? Okay, here we only take three points per, we only get 3 points per layer. Okay, we sample the orientations and we get the orientation data frame. Okay, so this is the orientation data frame, and then we store that as orientation. Okay, that is amazing. So here on the scripts, we also have some visualization, so that work with working functions. So here we run the plot orientations. So we open the orientation, we create the data frame, we define the row size and the legend size, and then we have a representation of the orientations together with a representation of the bottom of T and the bottom of TO. Okay, for the lines that come from the polygons and for the dummy points. And then we also create some BTK because maybe we need that in order to compare to interpolated surface. Okay, and this will be created here, these ones, these two, and as well as here. Okay, so in the VTK you will create this file, and these two folders. Okay, great, great, great. So let's continue. Well, the next part, actually, I'm going to delete. Okay, so we go to aquifer.hatarilabs.com. Okay, you sign in. Oh, okay. So we delete, so this will be sedimentary layers. Okay, great. Upload. So we go to edit, we go to the containerized apps, we create our pod. If not created, you create our pod. And then we go to view. Okay, so from the process and mostly from the AOI, we got the X-mean. Okay, so this will be the X-mean. This is the X-max. This is the X-max. This is the Y-mean. This is the Y-mean, and this is the Y-max. Okay, for the vertical direction, okay, that will depend on your data. Okay, so that will really depend on your data. So will be 140. Okay, so if you want it to be more taller, or that is up to you. I mean, that will also depend on that, on the bottom of the range of the bottom elevation for every layer. Okay, and on the resolution we have 87, 69. So our cell will have a width of 100 meters, and we are going to work with 50 layers. Okay, we are going to use the data, and we have strat 1. So which is the DEM file? The DEM file is this one, raster the DEM file. Okay, and it says that the DEM file is intersecting the area. Next, we have the orientation file that is on the CSV. Okay, this is the orientation file. Next, and we have the surface points. Okay, great. So that is amazing. Okay, it's T and TO 1 and 2. Upload. Great. So we go to plots, and then here we have them, and then we have here the points of T and TO, as well as here and the orientations, and also. Okay, so okay, the model is too heavy for being run on the platform, or I don't know, maybe you can run, but in order to be sure, we are going to work that on the local on our computer. Okay, so that is not hard science, so we have just to download the project. So the project is downloaded. Okay, here we have, and then here we extract, and then here we have the Gempy app. We do Control-C, and on this folder we are going to delete this one and paste the one that we have created. Okay, and here on P3, no, here on P2, we are going to fix this Gempy total script, because this Gempy total script is is for to be run on the cloud, but now we have to fix it in order to run on our computer. First here, this will be, okay, go to the first, okay, so this will be gempy.log. Okay, great. And then here that will be 2 points, relative path, and this is relative path, and this is, we have to just delete it. Okay, yes, 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 yes. Okay, we save it, and then we open another Anaconda prompt, cd documents, cd modeling, cd Gempy app, cd p2, and then here we launch the Python script. Okay, that might take some minutes. Okay, I'm going to put my stopwatch in order to give you the exact amount of minutes that this takes. Okay, so this is Python Gempy total app, total script. Okay, and okay, so okay, I'm going to make a pause here. Okay, so it has finished running on my stopwatch. That it has run on 8 minutes. Okay, so it's finishing. And well, that depends on the amount of cells and depends on the size. Okay, depends on your processor as well. The amount of time that will take for you. Okay, so let's continue. Okay, okay, so it has finished. So that's it. So there is still one code here on the scripts that makes the then process. Okay, so it makes the from the dem it creates a dem.vtk, and it also do a representation of the top layer and the bottom of each layer, and the surface that represent the bottom of each layer. Okay, so those are here. Great. So let's see, and okay, so we are going to do on ParaView. ParaView, we are going to explore the results. So first of all, let's open the lithology. What is the lithology? It's in documents, it's in modeling, it's in the Gempy app, it's in P3. Okay, and then we have the lithology. Okay, great. The lithology we are going to represent as surface. So that is the lithology, but since we have a dem file, we have to do a threshold on the lithology, because actually whatever is above the dem has an index of 0, and whatever has no value has an index of -4. So we have to do a threshold over that. So it will be from 1 to 3. So it will be whether TE, whether TO, or whether the basement. Okay, great. So this is the final geological result. Okay, and then we can do a cross section. Or for example, I want to do just one. So this will be my lithology of one. Okay, great. So here I will do another trace. Why I will do another threshold that will be from 1 to 3, apply, okay, and then I will do a clip, okay, and invert. Great, great, that is amazing. But as well, we need to do some vertical exaggeration because it's kind of very flat, this, so we need to do a vertical exaggeration. Okay, as well of 10 here. Okay, so this is so we can also import the surface, okay, the surface of the surface 2, for example. I can import that, so that will be this one. Okay, so we gave some elevation, and as well we gave some color. Why we gave some color? Because it has to pick the color of the lithology 2, that is this one. Okay, great, and let's take it out some opacity. Oops, or no, this is the diffuse, sorry, the opacity is here. Okay, great, so that looks amazing. And then we have also on the BTK, we have the dem.btk, apply. And the dem.btk has to be, okay, the dem.btk, we can do a clip on that. Let's see from this side. Okay, invert. Okay, apply and exaggeration. Okay, and that's it. And that is great, because here we have a great example of our, since the dem, I can make it a little bit higher because it's actually chief translation thing. No, the clip of the BTK, I'm going to make it higher. 10, 20. Wow. 30, 50. Well, because it's actually, no, there is no point to doing that. Okay, so this, yes, for this side. So for here, we do have the, for this surface with edges, and the edges will be off. Yeah, so this it is the representation of the geologic. This is the interpolated, the TE, this is the TO, and the other is the basement. We have that as a surface. We have the lithology. You have the code on the description. Okay, we hope, my recommendation is that you actually follow the tutorial and then try to put that with your own data. Okay, but by following this, and then we are going to release as well more tutorials on this topic as well. Okay, so this will be everything for my part, and have a great day. If you like it, please share, and have a great day. Bye bye.